Today in this video, we're going to be doing some civil FE exam review, and we're going to be focusing specifically on statics. So I have some practice problems for you all, and I want to get straight into the content. So let me minimize myself, and let's start by going through what we'll be covering today. So for those of you who follow the channel, you know that I go through every topic in the FE manual. And so today we're going to be talking specifically on frames and trusses. So I'm going to make two videos on this because these are some good problems that they could throw at you. So we want to, go ahead and dig into our practice problem. And as you can see to the right, we have this truss, so to speak, or it could be a frame. Either way, it looks like we have a roller to our right and a pin, and then we have a few downward forces and a horizontal force actually coming on it. So basically what this problem is asking is for us to determine the external reactions and to determine internal forces in the member AB, which is here, and AC, which is here. So first, let's just start by saying, okay, can we use the FE manual for this? And they want us specifically to do this problem using method of joints. So I don't know if you remember method of joints, but something that we can for sure look, in the handbook over here. I'm drinking a lot of water and belching. That is not what you all want to hear. All right, so I'm just going to search in the handbook method of joints. All right, it's only two things that come up. So method of joints, and this is the first one. Okay, so one tells you the page number that it's on, and then the other one comes up. Okay, so it says plane truss method of joints. The method consists of solving for the forces in the members by writing the two equilibrium equations for each joint of the truss. So it just says the horizontal forces and member components, the sum of them is equal to 0. That's what this says. And then the vertical forces and member components, the sum of those equal 0. So let's go ahead and start this problem. That's all the information they give us. So I think we can remember some of the forces for now. So I'm going to minimize that and just have our problem up here. All right, so let's first determine the external forces. Okay, so it literally, you have your picture to the right, so I'm not going to redraw that. What I will start by doing is let's just see if we can do the sum of the forces in the x-axis to start. See if we can solve, this is a point that I did not mention. Your AX, your AY, and your DY, those are your external forces, or your external reactions, I'm sorry. So that's what we want to solve for first, right? That's very crucial. So in order to get that, we have to we have a lot of unknowns, but we do have some forces. So if we try to do the sum of the forces in the horizontal way and the sum of the forces in the vertical way, it should start crossing out some variables or taking some moment. So we're going to try all of our luck and see what we come up with. All right, so sum of the the sum of the forces in the X is equal to, all right, we have AX, all right, and it's pointing to the right. That's just how we have it drawn for now. That it may be drawn the wrong way, but that's what we're going to assume it is for right now. All right, and then we have also another 10 newtons, as y'all can see here. So, and that is in the positive direction. All right, do I have any other horizontal forces? I don't see any, so I'm getting a X is equal to negative 10 newtons. Okay, so that just means instead of that horizontal force going to the right, it's just going to the left 10 newtons. Okay, let's do the sum of the forces in the Y. So that's one of our external reactions. So we got one of the three. That's not bad. So some of the forces in the Y, we got AX, I meant AY, I'm sorry. AY, and it's in the positive. That's how we have it drawn. And then we have plus DY. Okay. And then we got minus 10 newtons. That's this one. Okay. So I've got an AY, got DY. I got my 10, and there's one more at joint C. So minus another 10 newtons. So that's not really giving us anything, right? Still two unknowns, not really helping our case, right? All right. Just looking at this, and the last, really the last thing you can do is start to do a moment, or to take a moment in some location so that it gets rid of some of the variables that you have. So I see if I take a moment at D, right, I'm still going to be left with, well, will I be left with anything? Not really. I don't think so. If I take a moment at A, it'll just leave me with dy to kind of deal with. So just for this, I'm just going to take a moment at A. It seems like it might be easier. Both of them should give me a variable though. So the moment about a joint A is equal to, okay, this is where direction and positive and negatives are very crucial. I've been getting some questions in the comments about, is sign important? The way the answers that you're getting, yes, your positive and negatives are super crucial. So we're just going to say for this particular example, anytime that we take a moment and that it goes counterclockwise, that is positive. Okay. What I mean by counterclockwise is I'm about to take the moment now. That will that's going to be dy, and I'm saying dy is a positive, because if I push up, if I basically hold this point, right, at point A, and I push up on dy, this thing is gonna basically rotate, all right? And it's going to rotate in the counterclockwise position. So that's why I'm saying it would be positive, just by the way I have it drawn. Okay, and you're going to multiply it by the perpendicular distance, which is 5 meters in this case. Okay. As you're taking, you're looking at your next point. All right, we got a downward or a negative 10 Newton force coming at 5 meters, right? And we also have, I didn't put the meters beside that, but what else do we have? Okay, so took my UI. And another, wait, did I do that wrong? I feel like I did. No, I actually didn't. Sorry. So that is a negative. Okay. And then we got one more negative. So the first negative 10 times 5 was this one coming down, and then my perpendicular distance is 5 meters. And now I'm doing the moment for this horizontal force, which is still gonna be a negative 10 newtons. And then it's still 5 meters from my moment at A. All right, so is there anything that I'm missing? I could take a moment. Being that I'm taking my moment, there's another force that I'm neglecting, and it's only because there's no horizontal distance from my moment. So if I was to do it, it would be negative 10 newtons. And then it would be times 0 meters because the perpendicular distance, the perpendicular distance from my moment at A is 0. It's like straight up and down. So that is really, I really didn't have to write that down, but just for the concept. All right. So I'm getting, this is negative 50, negative 50. Is that negative 100? Negative 100. And that's meters. And then that's not 100. Okay. dy times 5 meters. And you shouldn't skip steps, so I'm gonna try to make sure I'm being step by step. So that was negative 50, minus 50, negative 100, and then minus 0. All right. Okay, I'm gonna swing my 100 meters to the other side. Yep. So feel free to skip ahead if you're going faster than me because I recognize I'm going slow. I'm currently filming this at 1:20 a.m. So bear with me. All right. So we know that dy is equal to should be 20 newtons. Okay. And now that I know that, all right, so that just lets me know that I drew that correctly, my arrow upwards correctly, which makes sense. If you got negative 10 minus 10, and then this one is 20, right? This force is going to be 0, but I'm going to, I mean, that makes it kind of throws me off a little bit, but it makes sense. So the sum of the forces in the y now is equal to, and I'm just taking this equation because we already wrote it out. So AY plus 20 newtons minus 10 newtons. And then minus, what else? Yeah, 10 newtons is equal to 0 plus AY. Now 0 equals AY. So even though we drew this arrow upwards, it's really like there's nothing there, 0 force. All right, so we have, all right, let's just write our, so that is the first part. We found now all of our external reactions. So our external reactions are AY is equal to 0. What else? AX is equal to negative 10 newtons. And this is very important because we'll need to know how to draw this for the second portion of our problem. And then we got AX, yeah, AY, and then what's DY? DY is equal to 20 newtons. All right, so I'm going to erase everything else, and now we're going to start our the second portion of the problem. So we did part A, and now we're going to move on to part B, and that is to determine the internal forces in the member AB and AC. So let me erase this. If you are finding some value out of this video, please make sure that you like it. Subscribe to the channel if you have not. Feel free to check out any of my previous videos. Also have a lot of stuff in the description bar, as well as some links to different programs to help you pass FE. If you want to work with me personally, you will have that opportunity. You can click on the link to work with me, and also have like more practice problems and solutions, and where I'm getting a lot of these problems, so that you're able to do this completely on your own. So, okay. So, just a quick refresher. This is why it's important to know your concepts and to understand what you're doing on this test. Like, all of this information has to be kind of like clockwork once you get in on the test. So I want to touch on it now. So the cool thing about method of joints is, for this particular truss, if you're looking at the joint, there's things that are always happening on the joints, right? And I'll just, for joint B, we have a downwards force of 10 newtons. We have either a downwards or upwards force. That's not a good representation. All right, I was trying to draw the member, but that wasn't very clear or very straight. So you have your joint. still not straight, but so let's just say at this joint, we have a downward force. All right. Is that clear? And then whatever, just always remember, because this still isn't good. Whatever force or whatever is happening on the joint, it's happening opposite on the member. So this member, if there's a downward force acting on the joint here, then there's an equal and opposite. Oh my God. Jesus. I thought I was getting better at this, but clearly not. There's always an equal and opposite force acting on the joint. So this is a very important concept for as we're drawing this information to be able to solve our internal forces. It's a very important concept. So hopefully that makes sense. Whatever force is acting on the member, the same force is acting equal and opposite on the joint. So hopefully that was stated clearly. Okay. So we have this. So method of joints works just as you kind of stated. So you break it up by its joints. And that will determine what is the equal and opposite force acting in on the members. And that's the force that we need to know, right? So this downward force or upward force, depending on if we drew it correctly, will let us know, know what is our the force in member AB. So we have, as I'm drawing this out, so this is joint B. Okay, all right, this is joint B. Okay, so at joint B, it's a downward force, 10 newtons, and then there's a force, downward or upward force in member A, B, right? And then there is a horizontal force. And I could be drawing this right or wrong, and that is in BC. BC. Okay. Oh God, my handwriting is so bad. But anyways, that's beyond the point. Okay. So now for our method of joints, right? We are going to always do like we've been doing and do the sum of the force in the X, the sum of the force in the Y, and determine some of these forces within the members, right? So for this, for member, for joint B, sum of the forces in the X is equal to BC, right? Got nothing else for that. So really, it's looking like BC is equal to 0. Okay. The sum of the forces in the y is equal to, so we have a negative 10 newtons. And then we have a minus AB. All right. Okay. And so now we know that AB is equal to negative 10 newtons. Okay, what does that mean? That means that AB was drawn incorrectly, right? It's not downwards, it's the other way. So this is the position. It's up. But this is the position on the joint. Okay, very important. So what I'm going to do is to make your life easier, if your number comes out a negative number, just please draw it the right way. This is very, very important. Just go ahead, and that would make sense, right? Because this would balance, right? If there's a downward force, you would think you would draw upward force to balance it out. This is very, very important. Okay, so knowing that, let's look at our member now. God, I need a feature. If y'all know of a place where I can do this and it just give me like a straight line, maybe I can do some research. My straight lines have to improve. All right, so this is the member, AB, right? Remember what I said, it's equal and opposite. So whatever's happening at the joint, the opposite is happening on the member. So this is really important when it comes to tension and compression in the member. So remember, whatever happens at the joint, opposite on the member. So I know that I'm having some I know that this is in compression, all right? Because basically we're pushing in on that member. So that means it's in compression. Now, if we were pulling, they were going the other way, then it would be in tension. But we now have the internal force in AB, which is the first portion of part B. And now we want to know AC, right? Okay, so what are we going to do again? We're going to look at the joint of C. Maybe I should erase everything, but we're going to just see how I go about it. So this is joint C. So I know that I have an equal and opposite, all right? So if it was pointing upward at my member, it should be pointing downward at my joint, and this is 10 newtons downwards. It's not negative 10, it's just 10 newtons because I have it drawn correctly. Now, if I didn't have this arrow drawn correctly, it would be a negative. So just make sure that you completely understand your positive and negatives and where compression, tension is happening. Hopefully, I'm explaining it properly, but if I'm not, I can go back and make another video or so because this is, like I said, this is a very important concept. Okay, so probably drew that in the wrong location because we have some more forces that we're gonna need to draw. All right, so that's a 10 Newton thing, but okay. So just imagine everything that's happening at, oh, I said this was C. This is not C. This is A. Get it together, James. And I know listening to professors, whenever they said, oh, my fault, my bad, like it would irritate the shit out of me. So my apologies. My apologies. All right. So at A, we have this downwards force, AB, right? What else do we have going on? Well, we have or do we have an upwards force? No, AY is 0. Remember, AY is 0, so we don't have that force that we even have to worry about. AX, well, AX is negative 10, but it's just saying that we drew it wrong, right? So let's just draw it wrong again. And really, you should probably be consistent with how you do things so it won't confuse you. So I'm just going to say that's AX, but I know that I'm drawing it wrong on purpose, so I can just plug and chug. Yeah. So just make sure your signage is right. So we have that. And then we have this beautiful force going everywhere, going this crazy way. And this is force AC. Okay. It's trying to get to that other joint. Are there any forces that I missed? Hopefully not. Okay. So just looking at this, it looks like if I do a sum of the forces in the X or in the Y, let's just see what we get. So sum of the forces in the X is equal to AX plus AC I don't know why I drew it like that. It's not like a sub anything. All right, plus AC. And then it's just not plus AC, all right? It's just not completely horizontal, but we do want to get the horizontal version of it. So this comes back to our kind of sine and cosine. So since we want to get the horizontal, we're going to do 5 over the hypotenuse. So what's our hypotenuse? Well, if we got one that's 5, another that's 5, right? 5 squared plus 5 squared. All right. Let me get my calculator. I think that's the square root of 50, but we're doing our hypotenuse is going to be 5 squared plus 5 squared. So we got 5 this way, 5 this way. If we take the square root of it, it's going to give us our hypotenuse. So that's all this bottom thing is our hypotenuse value. So 5 squared, this is 25 plus 25. Take the second square root of that, and it's just the square root of 50, right? Okay. So, is there anything else that we need? I really don't think so. Okay, so we know that what we got? Make sure there's nothing else. Yeah, I think that's it. So let's do, that means this is negative 10 newtons plus AC times 5 divided by the square root of 50 is equal to 0. 10 is equal to 10 is equal to AC 5 divided by the square root of 50. So 10 times the square root, 10 times the square root of 50 divided by 5 gives us AC. So let's see if we can get that answer. So 10. All right, so I get AC to be 14.14 newtons. And that means that I drew it right because it didn't come out negative. So if we're just looking at that, hopefully it's okay for me to, we got AB. Yeah, so you all know what AB is. Hopefully you will write that down. But I just want to show you what this really means. So remember our joint, what happens on our joint, there's always your member. Oh, that was pretty straight. That's pretty straight. I like that. And then of course my joint C is over here. But we're focusing on this member right now. So being that I drew this correctly, this force is going out this way. There's an equal and opposite force happening right there. And okay, so what does that mean? What do these arrows mean? They're very important. It's pulling. It's pulling AC, all right? So that means this is in tension. And they will ask is something in compression or in tension. So it's very important. That handwriting is god awful. But anyways, yeah, they will ask this information. So we just went for 40 minutes, way too long probably for a problem, but hopefully this was clear and in depth. Be sure to like the video, and don't forget to check out all the other content that I have created, because I go like in depth. I want to show you literally every step, because I think that's like crucial. You got to know what you're doing and feel comfortable so that you're able to pass this exam. So just want to cover what the next video will be on. So we've gotten through resultant forces, equivalent. Yep. So frames and trusses. I have one other video where I'm going to be going through the method of sections, I do believe, and then we'll be done with frames and we'll jump over to centroid of area. So hopefully this video was helpful. I enjoyed creating it. So I'm looking forward to seeing you all in the next video. Peace.